So you're building an AI application. You've spent weeks, maybe even months, tweaking your prompts, and you've hit a wall. If that sounds familiar, it's because you're probably focusing on the wrong thing. Let's talk about the hidden multiplier that can absolutely transform your AI's capabilities: context engineering.
For the longest time, right, the whole conversation has been about prompt engineering. And don't get me wrong, it's important. It'll give you a solid 2, maybe 3 times improvement. But just look at this. Context engineering. We're talking a massive 5 to 10 times performance boost. That's not just an improvement. It's the difference between a pretty clever chatbot and a genuine expert system. This is where the real leverage is.
And it's not just about raw performance. Check out that number, a potential 70% reduction in your LLM costs. Yeah, by being smarter about the information you give to your model, you can slash your token usage. At scale, we're talking about saving thousands, maybe even millions of dollars. This isn't just some minor tweak, it's a completely different economic model for your AI. So, what is context engineering really? Well, put simply, it's the whole process of carefully selecting, structuring, and delivering information to your large language models. Think of yourself as a master curator. You're not just throwing a book at the AI. You're giving it the exact page, the exact paragraph it needs, no more, no less, to do its job perfectly. I love this quote because it just nails the difference. Prompt engineering teaches the AI how to think. It's about crafting that perfect instruction. But context engineering, that teaches the AI what to think about. It provides the perfect curated universe of knowledge for that instruction to operate in. One is the command, the other is the entire library.
Okay, so how do we actually put this into practice? Let's get into it and walk through the 5 core techniques that are going to make up your context engineering toolkit.
First up is intelligent chunking. Look, your knowledge base, whether it's internal wikis, code repos, support tickets, it's huge. You can't just dump all of that into a prompt. So chunking is the art and science of breaking all that information down into small, meaningful, easy-to-find pieces that an AI can actually retrieve and make sense of. And this is so important. Not all chunking methods are the same. Fixed size is simple. It's great for uniform data like system logs. But for your actual documentation, semantic chunking, which splits things up by paragraphs, is way better because it keeps the core idea together. For really complex technical docs or code, you want to look at recursive chunking. And for high-stakes stuff like legal or medical documents, the sliding window method makes sure you never lose critical info between the chunks. The bottom line is, you have to match the chunking strategy to your data. All right, technique number 2 is priority ordering. Now, this tackles a really fascinating quirk of LLMs. Just like us, they have this lost-in-the-middle problem. They pay a lot of attention to what they see first, that's primacy bias, and even more attention to what they see last, recency bias. This means any crucial details you bury in the middle of a long context, they often get completely ignored. So the solution is just beautifully simple. It's called the sandwich pattern. You structure your prompt like, well, a sandwich. The most critical user instruction goes right at the top. That's your top slice of bread. All the supporting documents and examples, that's the filling. It goes in the middle. And then, and this is key, you repeat or reinforce the main task right at the very end. That simple reordering can boost accuracy by up to 30%. It's incredible.
Technique 3 is all about structure. It's not just what you provide, it's how you present it. See, LLMs were trained on the internet, on highly structured data, so they are amazing at parsing formats like XML or JSON. By wrapping your context in clear descriptive tags like user profile or relevant docs, you're basically giving the model a perfect roadmap. The result? A 40% higher accuracy in using that information correctly.
And now for the big one, RAG, which stands for Retrieval Augmented Generation. This isn't just another technique. Honestly, this is the production standard architecture that brings everything we've been talking about together.
Let's just quickly walk through this flow. A user asks a question. First, we turn that question into a string of numbers, an embedding. Then, we use that embedding to search our vector database, which has all our pre-chunked documents. We grab the most relevant chunks, assemble them into a perfectly structured context, using our sandwich pattern, of course. And then finally, we send that curated package to the LLM to generate a really accurate, grounded answer. And if you're running this in production, you absolutely have to measure it. These are the kinds of targets you should be aiming for. Is your retrieval step actually finding the right documents? That's precision. You want that above 85%. Is the final answer correct? That's accuracy. Aim for over 90%. And maybe most importantly, Is the answer actually based on the context you gave it? That's faithfulness, and you need that above 95% to stop hallucinations in their tracks. Okay, our final core technique is memory. A single question and answer is useful, but the real value, the real magic, is in a coherent, back and forth conversation. Memory systems are what allow the AI to remember previous parts of the chat, to keep track of things, and to maintain state. It's what turns a simple Q&A bot into a true digital partner. So having the right toolkit is one thing, but it's just as important to know what not to do. Let's go over a couple of common anti-patterns that will silently kill your performance and just burn through your budget. The number one mistake I see people make is context dumping. The thinking is, hey, the context window is huge. Why not just throw everything in there? As you can see here, that is a terrible idea. It's noisy, it's slow, and it actually lowers your accuracy. Being targeted, providing only the top, say, 5 most relevant docs is always better. Don't make the LLM search for a needle in a haystack. Just give it the needle. And that leads right into our next pitfall, ignoring the cost of tokens. Just look at these numbers. A bloated 150,000 token request could cost you $4.50. A single request. An optimized 15,000 token context, it not only gives you a better answer, but costs just 45 cents. That is a 10 times cost reduction for a better result. Being a good context engineer means being economically efficient. Whew, okay, we've covered a lot of ground, so let's just boil it all down into a clear blueprint with the most important takeaways. First, always remember, context engineering is where the real gains are. It's 5 to 10 times more impactful than just messing with prompts. Second, for any serious app, RAG is the production standard. It's your go-to architecture. Third, a simple trick like using the sandwich pattern for ordering your context gives you a huge, almost free boost in accuracy. And finally, always optimize for cost. Be smart about retrieval and context compression. So, if you remember nothing else from all this, let it be this. What you provide matters so much more than how you ask. The quality, the relevance, and the structure of the information you feed your AI, that is the single biggest factor in its success. To really master these techniques and start building some truly high-performance AI systems, make sure you subscribe to Gheware DevOps AI. You can find way more deep dive tutorials on AI and DevOps engineering over at brainupgrade.in. Thanks for watching.